In today's video, we're going to take a look at both the group 7 elements, known as halogens, and the group 0 elements, known as the noble gases. And we'll run through the properties and the trends of each of them. Let's start with the halogens, which are all in some way pretty dangerous. Fluorine is a poisonous yellow gas and is very reactive. Chlorine is less reactive, and this time a poisonous green gas. Bromine is a reddy brown volatile liquid, and poisonous again. And iodine is a dark grey solid that can form poisonous purple vapours. Although iodine is also an antiseptic, which has saved millions of lives. And for those last two elements, astatine and tennessine, you can basically ignore them, because they don't really come up in the course. All of the halogens can exist as pairs of atoms that we call diatomic molecules, which just means two atom molecules. They do this by sharing electrons and forming a covalent bond, as we've shown here for chlorine. Although this outer shell arrangement would be the same for any of the halogens. Halogens can also form covalent bonds with other nonmetals, such as hydrogen or carbon, to form compounds like hydrogen fluoride or carbon tetrachloride. These compounds are known as simple molecular structures, and we take a closer look at them and the covalent bonds that they use in another video. Just like the group 1 elements, group 7 also has trends as you go down the group, but they're the opposite way around. So for halogens, the melting points and boiling points increase as you go down the group, and the reactivity decreases. This decrease in reactivity is because as you go down the group, the outermost shell gets further and further away from the positive nucleus. So the attractive force that's needed to pull in an extra electron from another atom gets weaker. And if the halogen can't attract an electron to complete its outer shell, then it can't react. So the larger atoms at the bottom of the table, like iodine, are the least reactive. The next thing we need to look at is how halogens form ionic bonds with metals. When a halogen gains an electron to form a 1- ion, we call it a halide, and we have to change the name slightly, changing the N's to D's. So we get fluoride, chloride, bromide, and iodide, all of which would be ions. You'll probably most often see halogens forming ionic compounds with the alkali metals in group 1, like sodium chloride as we have here, but they can form ionic bonds with metals of other groups too. Lastly, we need to take a look at displacement reactions. These involve a more reactive halogen displacing a less reactive one. For example, let's imagine that we pumped some chlorine gas into a solution of potassium bromide. As the chlorine is more reactive than the bromine, because it's higher up in the group, it displaces the bromide to bond to the potassium. So effectively, the chlorine has taken the bromine's place to form potassium chloride. The main thing to remember here is just that more reactive halogens will always displace less reactive ones. For example, fluorine, chlorine, and bromine could all displace iodine, as iodine is the least reactive. Now, we were going to do an entire video on the group 0 elements, which are also known as the noble gases, but there really isn't that much that you need to know. They all exist as colourless gases, and because they have full outer shells, they're inert, which just means that they don't really react with anything. And because they don't react with other atoms, they exist as single atoms, and they're also non-flammable, which means they can't be set on fire. The only other thing that you really need to know is that their boiling point increases as you go down the group, just like it does for the halogens. If you haven't heard yet, you can find all of our videos on our website, cognito.org. You'll also find questions, flashcards, exam-style questions, and past papers. And we track all of your progress so that you always know what to study next.
So sign up for free by clicking here or browse our playlist here on YouTube.